A performance scenario typically involves three key components: the action being performed, the conditions under which it occurs, and the expected outcome regarding system performance. The action can be user-driven, such as logging in, submitting a form, or uploading a file. Or it can be system-driven, like processing background jobs or syncing data across services. The conditions specify the environment or setup in which the action occurs, such as server load, network speed, or data volume. The expected outcome defines the performance targets, such as response time, throughput, and resource consumption, which help gauge the system's efficiency. There are several types of performance scenarios, each focusing on a different aspect of system performance. The first type, response time scenarios, measures how quickly the system responds to specific requests. For example, a scenario could state, when a customer clicks the Add to Cart button, the confirmation message should appear within 1 second. This type of scenario is crucial for ensuring that the software feels fast and responsive to users, especially for actions that users perform frequently. Another important type is the throughput scenario, which evaluates the system's ability to handle a certain number of operations within a specified time frame. For example, a scenario might be, the API should be able to handle 200 requests per second for retrieving product details without experiencing degradation in performance. Throughput scenarios are particularly important for high-traffic applications, where multiple users may be interacting with the system simultaneously, and it's crucial to ensure that the system can process these requests efficiently. Resource utilization scenarios are another important category of performance testing. These scenarios focus on how much of the system's resources, such as CPU, memory, disk space, or network bandwidth, are consumed during specific operations. For example, generating a PDF invoice should not consume more than 30% of CPU on a standard server instance. These scenarios help ensure that the system is efficient and does not unnecessarily drain resources, which can affect overall performance and scalability. Concurrent user scenarios test how the system performs when multiple users perform the same or similar actions at the same time. While load testing typically deals with very high numbers of concurrent users, performance scenarios might focus on lower concurrency levels. For instance, a scenario might state up to 20 users can search for flights on the website simultaneously, with each search returning results in under 3 seconds. This ensures that the system remains responsive when multiple users are accessing it concurrently. Another category of performance scenarios involves cold start or first-time use testing. These scenarios evaluate how the system behaves when it has not yet cached data or initialized certain processes. For example, when a new user logs in for the first time, the system should set up the user's environment and load the dashboard within 5 seconds. These scenarios are important for ensuring that first-time users have a smooth experience without long delays, especially when initial setup tasks are involved. Background processing scenarios test the performance of tasks that run in the background, independent of user interactions. These tasks could include data synchronization, report generation, or batch processing. For example, the system should generate weekly financial reports for 10,000 users in under 30 minutes. These scenarios are crucial for ensuring that background jobs do not negatively impact the overall system performance or delay other critical processes. Error handling performance scenarios are also essential, as they test how the system reacts when errors occur. These scenarios measure how well the system can recover from failure and how quickly it responds to users. For instance, if a payment fails due to a network timeout, the retry mechanism should kick in within 3 seconds and notify the user of the issue. These scenarios ensure that the system can handle errors gracefully without impacting the user experience. Lastly, data volume scenarios evaluate how the system performs when handling large amounts of data. For example, when retrieving a user's transaction history with 5,000 records, the system should return the data within 4 seconds. These scenarios are important for identifying performance bottlenecks that may occur when dealing with large datasets, ensuring that the system remains scalable as the data grows. By defining and testing these various performance scenarios, developers and testers can identify and resolve potential performance issues early in the development lifecycle. This proactive approach helps ensure that the software can handle typical usage patterns, deliver a fast and efficient user experience, and perform reliably even under varying conditions. Performance scenarios are usually implemented using performance testing tools like Apache JMeter, Gatling, LoadRunner, or cloud-based services such as Azure Load Testing or AWS Performance Insights.